Hey guys, welcome back. Today we're going to do a short crank 3-rotor PP engine. Now this particular engine is going to go into my own car. It'll go into one of the RX-7s, another Stuyvesant car. So yeah, we thought we'd do a video on it and show you what goes into it. We've got the boss in today to give us a hand. You want to say hello, puppy? Yeah, you want to get out of the way so we can do some work? So with this engine, we're starting off with FC Series 4 turbo plates. We've been importing engines for 20 odd years now, and over the years, the Series 4, even the Series 5, the early stuff, it's not in high demand, and we've been left with a lot of shitty engines that have just had water in them, ones that have been modified or rebuilt in Japan. They've had blow-ups. So out of that, we try and salvage as many usable parts as we can. But for my own stuff, what I've done is I've gone through the scrap pile and got what I think is suitable. And for myself, this will be... Now for this build, we'll use the 3-rotor short crank from Precision Engineering. This is not an X40, this is just the off-the-shelf. This is for your naturally aspirated stuff. Now these are about $3,500 odd, and yeah, perfectly fine for the job. We've already gone ahead, or I should say I've gone ahead and I've done all the monotonous work and measured all the journals. Now we've got 3.5 on the front gear, 4.5 on the middle gear, and 2.5 thou clearance on the rear. For the rotors, we've got 2.5, 2.75, and 2.5 bearing clearance. Now the machine work's already been done on the plates. The way that I do that is measure the front, stack a rear on it, measure the rear to find your absolute center for the crankshaft line, then position your rear plate up, and we'll machine that to install the gear. Now obviously all that's already been done. It's a very time consuming process. It's all done manually. So that has been done, and we might do a video at a later date on doing one of those engines, or doing one of these engines, and show you what is involved. But that has already been done. Now for the rotors in this engine, I'm using FD rotors. I wanted to do a light assembly, or as light as possible assembly, and I didn't want RX-8 rotors. Now all of these rotors would be considered fucked. They all have a defect in one way or another. Some of them have had water in areas, sitting in areas. I think this one has had a broken apex seal. This one's just a pure casting flaw. I'm not sure if you'll see it, but you can see there the pocket's just different. Where the rotors have been, I mean, obviously we do machine work to try and bring these things back to right. And if you have a look, the main critical areas for the rotor, in my opinion, is if your apex seal slot is straight and true, you're not flared out on the ends, your side seal slots are true and free, that you're not having your side seal jammed up. Your corner seals are able to spring in and out. They're not sloppy, or they're not super tight. You don't want them going in and getting jammed, obviously. Now you'll see on this rotor here where all three of these rotors have been lightened. They've been face clearance and tip clearanced and side clearanced. Now a quick example of this one, you can see where it was tip clearanced, but when we get to the edge here, we've got a nice straight line. You can see where this rotor actually dips off. Now you would probably never ever have picked that up. You would have, if this was brand new, you would have pulled it out of the box, looked at it, measured your slot, put your apex seal and went, yep, that's good to use. It's not until we've actually put this one up and machined it that we've gone, you know what, that was actually a low point. You'll notice on the next two, we've got nice parallel lines, so those tips were actually fine. When face clearancing the rotor, you'll see on this one here, now the radius, the shape of the rotor, you can see we've taken the meat out of or we've taken material off the center. That's where it's most likely going to touch at high RPM. But if you have a look up at the tips, this one's actually low. This one was high, and this one was even higher in this area here. Now these are all set up and done in the CNC, so the machining process is the same. They go on the same jig. The only thing that's different is the actual casting differences between each of the rotors. And while the castings is the difference, they are all the same series of rotor. They're all an FD rotor, which is verified by the combustion chamber and the stampings on the rotor itself. which will tell you what series of rotor it is. Now we've lightened the rotors. Now I've taken as what I consider to be as much as safely possible. This one, because it's got nothing taken out of the core of the rotor, that was probably the lightest rotor. And then the other two rotors have had more internal lightening to get more weight out of them to match the front. Now these rotors, there you go, look at that. Okay, we've got some blemishes there. This engine has probably had water in it. There's some marks there, it's had a blow up. Now, as I said, these were destined for the rubbish bin. These were junk. Spending an hour or so on each rotor, it's made these a usable rotor for myself, not a saleable rotor. This is not something that I could put in an engine and send out to a customer. Some people say, oh, why'd you use an FD rotor? Because most of the FD engines we're building, we're putting new Series 4 turbo rotors in, so these were junk. So for myself, spending an hour on each rotor, it turns them into free rotors for me, which cuts down on the cost, obviously. So with the rotors lightened, the assembly's then balanced. Standard 20B front and rear counterweights. The rotating assembly is balanced, and then that is now right to go. Moving on to housings. Somewhere where I did spend some money was new housings. Now they're only Series 5 turbo housings. Obviously done some machine work on them. This engine will be direct injected. We'll just run 3 injectors into the engine here. Peripheral ported engine. It'll be probably just maybe make a manifold with a single throttle, or I'll see what else I've got laying around. Maybe even do both, and I'll back-to-back it. But I will, when this engine goes together, I will do some more video on it and show the engine in the car. We'll dyno the engine and see what sort of power it makes. We might even do 2 manifolds for it, and we'll dyno it and see the difference between an ITB and a single throttle with a plenum. Another thing that we do is we don't use any Celastics or silicon in the legs. We use a gasket maker, which is an anaerobic type sealant, meaning that it will not cure until there is a complete absence of air. The problem with the Celastics and silicons is that you put it down, and on a hot day, which doesn't matter too much in here because we're air conditioned, but in an area where it might be 30-40 degrees, it'll tack off quite quickly and form a skin. And when you start multi-stacking engines, they take longer to build. Therefore, your first coat of sealant may actually be cured before you get to the front plate on, and not completely stacking flat. It'll actually stack to start like an accordion. Okay, on to our first rotor to go down. As you can see, it's FD rotor. It's been lightened and clearance, face, sides and tips. We'll make sure that all the corner seals are aligned before we put it down. Now we're just running standard Mazda side seals, standard FD Mazda corner seal, and we'll use an aftermarket Apex seal. Now that the rotor's in position, we start with our first housing. Now, these are PP, nothing fancy, nothing crazy and wild. One thing we do check, whether they're new or used housings, make sure that there is no burrs on the feet or on the legs. If where you've sealed up, you've got a semi-PP, make sure that this is actually below the surface, not proud. Obviously that'll hold the housing up. Now this is a combination of, we use a 2-part epoxy inside, and then we cover that with a urethane and let it dry. It's watertight. Now with the Apex seals in, we're ready to put on our first plate. Just a quick check, everything's free. We'll put in a little bit of liquid love so we're not dry on the startup. So pop the crank in. Now next step is going to be to drop the next plate over. Now I'll remove the dowels for that. We've got the crank in the right position to make it as easy as possible to get over that lobe. Okay, with our water seals in, this one's ready to go on. Now, as you can see, this one is just a second-hand import FC iron that we're going to use. A bit of lube for the rotor. Now, I'm not going to be able to film and put this on single-handedly, so put this camera down. So with the plate on, our water O-rings in, we'll get this in position so we can pre-lube the crank. We'll get that in position, we'll drop the rotor on. With the center rotor installed, we've gone through, checked that all our corner seals are lined up in the apex seal grooves, so we can drop the housing on next. And we've been over, we've checked that all the legs, the feet, there's no burrs, no high spots. Surface is clean and ready to go on. Okay, with the apex seals in place, we just push them down. Okay, we'll put a bit of lube so it's not dry first time it turns over. What we'll also do at this point is that taper needs to be spotless. You can see it's been lapped, so we'll make sure that's completely dry before we put the next lobe on. Now, our next intermediate plate is the most important plate in the whole engine, in my opinion. The reason for that being is this plate has your gear installed for your middle rotor. Now, if that gear is not installed, not in the middle of this plate, but in the center line of your front and rear plate, it's going to give you issues in the long run. Bearing wear, rotor bearing wear, gear wear. So it is very important to get this one right. Now, the way these are installed is this plate's set up and machined, and the gear is a size for size press in, so to speak, and this circlip here is what stops that gear from coming back out. The only thing stopping the gear coming out the other way is a shoulder which is machined on the inside of the opposite face, which stops it pushing out. Now, on a cast iron plate, you can see there's not a lot of material at all to stop that, so it's a very finicky job. It's quite a satisfying job once you do get one installed and it hasn't broken a plate. I'll show you what the other side is like. So the gear carrier, which Jeff supplies, comes up to a shoulder on the underside of this face here. These bolt heads is what stops the gear from actually trying to rotate. Your oil feed line coming down here is just a brass tube. That's got no way, shape or form meant to stop this gear from turning. Your morning wood's got more tensile strength than that oil feed tube. So it's critical that the fitment of the gear and the heads is absolutely spot on. Otherwise, you're going to have a gear which is able to rock that way, and if your measurements from the underside of this to the back circlip are too loose, you're going to have a gear which will float like that. Because it's a size for size, you're not going to do it by hand, but when the engine's running, that's what's going to happen. This gear is going to want to move in and out, and it's going to want to rock. So the fitment of the gear to the center plate is absolutely critical. Now, the reason the design of the gear and the installation is all like this is because this is what was available at the time. This whole concept has been around longer than what the production Mazda 20B 3-rotor engine has been. This is what they came up with to make a 3-rotor engine. It was a year or two later before Mazda made a production 20B 3-rotor engine, and obviously they made a fatter plate, which is why this is a short crank using an intermediate plate. The extra width in the Mazda plate allowed them to bolt the gear into the back side of the plate, and it also allowed them to put a dowel pin to locate to stop the gear from turning. Now, with that all prepped and ready to go, we'll put that center plate on, and we're on the home stretch. Now that our center plate's on, we can put the front lobe on. It's a good time to check and make sure you've actually got some float in the crank, so nothing's bound up. Because the gear is now into that rotor, we also have the chance to actually rotate the engine, so we can put the nut on and turn it. What we'll also need to do is get rid of any oil off this taper. That is what locks your front lobe on. The key there is purely just a guide. That's what times the lobe. So we'll clean them up and get them on. So you want to make sure that the opposing taper is clean. No oil, no dirt. Make sure it is very clean. And we can put our key in and drop the front lobe on. And that's what you want. That has to lock. Very, very important that that taper locks on. Now's the time where you want to put your oil squirter into the crank tube, because it is your first and last chance to get that in before you get the rotor on. Okay, with that on, now we can put a nut on the front of the crank and spin it around. Quite free. So I'm happy with that. Okay, so our last housing's ready to go on. We've been over them, make sure they're good. Can't get complacent. But make sure they're all 100%. Rotor's on. Get a little bit of that. That's fucked. If it doesn't make power, that's why. Now, lucky last apex seal to go in. And now we're at a point we can put the plate on, seal it up, set the end float, and look at getting this into the car. Our front plate done, ready to put on. Ready for the front gear to go on. Now we've got a couple of bolts in the front gear, and we've got a couple of through bolts in so it doesn't fall over. We can sort of wind her over and check our end float. I'll put a front nut on it. Let's see what it's like to turn, make sure it's nice and smooth.
Do you get a V-band rehousing? That?
Which one?
The FD? Or is it stuck T4?
Yeah, V-band. Nice and free. Now that all the through bolts are torqued up, and we can check the end float on the engine. So we've got the stack on the front nut's being torqued up to spec being 10 ugga-duggers. We've got 4 thou, and I'll be happy with that. Now you should always check that your impact gun is calibrated correctly, so make sure your 10 ugga-duggers is alright.